This transformation is pretty simple. We have a bromination reaction of benzene, not once, 3 bromination reactions. So some of you might think that, sure, we need 3 bromine molecules, and then with the proper Lewis acid catalyst, like a ferric bromide, aluminum bromide, or whatever, that makes a electrophilic aromatic substitution reaction. Then I can introduce 3 bromine. Sure, this is a no-brainer, right? But what I need to think about is bromine is also parent directors, even though it's electronegative. The first bromine is put on, and that's going to direct where the second bromine should go, right? Second bromine is going to the para position or ortho positions. Let's put the para position first. Then it's going to another reaction happen. Then we're going to get the 3 bromine put on, but it's not the same as what we want to do. So that reactions is not going to make the product. Then how we're going to put the 3 bromine all better to each other? How can we do that? I mean, this is a kind of a very mind-boggling problem until we know the solutions. This is a kind of a trick, very tricky question. But once you see the solution, then you're going to realize that some of the reactions we talked about could be used on purpose. This pattern, bromine, metal to another bromine, metal to another bromine, does not really make any sense. But if I put amine there, then it all makes sense, right? Amine is a very strong ortho para directors. So this is an ortho to amine, that is an ortho to amine, that's a para to amine. So these can be easily prepared once you have aniline here. And then this reaction, you don't even need a catalyst because an amine is such a strong activators. So catalysts are not needed. We just need to add 3 bromine. Then we can put the bromine here, bromine there, bromine here. The problem is we still don't get an amine there. Only thing that we need to do, we have to get rid of the amine. And you know a reaction to get rid of the amine. So that's the reaction we talked about already. So first of all, where is amine coming from? It can come from the nitro groups, right? Because we cannot directly introduce an amine to the benzene. You've got to do the nitration first, and then do the reductions. That reduction can be done so many different ways, but let's say we're using a hydrogenation, but you can use a liquid hydride if you want to. These reactions are nitration reactions, nitric acid, sulfuric acid, that do this. So you can figure this part out. The thing is that in order to make a product, which is we have to get rid of the amine. So how to get rid of the amine, right? We gotta first convert diazonium, right? So the nitride HCl, make a diazonium ion. Then I hope remember the straight reagents. We talked about something called hypophosphorus acid. Hypophosphorus acid replaced N2 with the hydrogens. So that way, these nitrogens are taken away. So that is produced from that. Not by this way. That looks pretty simple because you recognize the bromine, so you thought that I can simply do electrophilic aromatic reactions, substitution reaction with the bromine, but you'll get the wrong product. In order to make this, you have to go around it, but the trick is putting the ortho para directors there so you can have these amine or metal to each other. Eventually, you get rid of amine by diazonium ion, react with the hypophosphorus acid, and you get to make the products. So I hope that you recognize some of the reactions with diazonium ion can be used very strategically